But the way we set this up, it's going to be very similar to the other day. I'm going to still be looking for 5 points within the span of one of those periods. I'll still be looking for them to be in the correct spot. So now you'll have to maybe move them up, left, right, whatever. But I'm still going to be checking 5 points, just like on Monday when I wrote it out. Okay? All right, so on Monday we had that stuff up there, right? I had it written like A sine B and A cosine B, where we had, right, with this you had, well, absolute value of A equals the amplitude, right? And the B that was up there, that's what you use to find the period, right? The period was 2 pi over B. Okay, so none of that's going to change. It's still going to apply today. You still need to be able to find this. You still need to be able to find that, because that's going to determine like how tall your graph is, and that's how wide it is. But when we set this up, I'm still going to set it, like when I do the graphs, I'll still do it so that you don't have to stretch them or shrink them. You can just alter the numbers on your x-axis and y-axis to correspond to everything, just so it'll save you a little time. Okay, now the new letter to add to it. This will be your vertical shifts. Okay, so the plus C, it has to be something that's not attached to the x value there. So it's like you take whatever functions we would have had on Monday, and like either in front of it or at the very end of it, without like parentheses and so on. If you think it's going to benefit you to do that, have at it. I'm not going to require you to graph like the original function and then the shift. Meaning, like, what I'm saying is, in other courses you would have to graph that, which would be the function without the shift. So it would have been like you did on Monday. And then you would take this graph, once you have it plotted out, and basically shift it up or down, or after this left to right, from your original. If you can get around not having to do this, it'll save you a little time, okay? But if you want to do that just to make absolutely sure that you're doing everything perfect, then that's fine also. I'll probably do the first one that way, just so you can visualize it, but then the next one I might not. Okay, so if I'm doing it the way of drawing out what would be like the original function, and then I'm going to shift it, all I'm going to focus on is this part right now, which is just like we did on Monday. So again, I would pull out whatever number's here, like the A, which is just 1. So I know my amplitude's 1, so it's not a big deal. So on my y-axis, I can make this a 1 and a negative. Okay. Then I would pull out my B number, which is 2. So that would tell me my period there should be 2 pi divided by 2, which is just pi. Okay, so the amount of marks I'm still putting here are still going to be the same. There's my 4. With that number right there always being the period. Correct? Right? And this first one here was always 1/4 of the entire period. So this is pi over 4. That's half of it, and then that's 3/4. Okay, so if I just used what's up there now and plotted what that general shape of the sine graph should be, I would get that.
Now, why did you do 4 points there?
What do you mean?
Like you had like 4.
Oh, it's always split into 4s.
Oh,
Every single time, yeah. Well, it's really it's split into a half and then a half again, but it's easier to just say do it as a 4th matter. Okay, so now this would have been like on Monday. So all I said is for some people this works fine every single time. It just takes like an extra step or two. And so now if I look at the actual equation I'm working with up here, it's saying that I'm taking this whole thing and then I'm adding 2 to it. So since that plus 2, the positive 2, is like away from the x's and stuff, I know that that is a vertical shift, And since it's a +2, that means I'm shifting this entire thing up 2 spots. So none of the things are moving in the x direction, everything is just going up. Meaning like this point right here, instead of being at 0, 0, when I shift it up 2, now it becomes to there to 2. So it's starting there. So this point after I shift it goes to here. All right. This point here, which is at pi over 4, 1. Now all I'm doing is shifting that 1 up 2. So the 1 changes to a 3. Okay. This point here, again, shifts up 2. This point down here, count up 2. That point. So the actual graph would be this one. Okay. This would be like the original. This is just something that you can do for work purposes in order to get the final graph. Like the one that's up here, that is your y equals 2 plus sine 2x. Okay, this was just sine 2x down here. This is just that shifted up 2. Okay? All right, one way to do it without graphing the base graph is to kind of draw like a fake x-axis. Meaning, my original graphs like that we did on Monday and your original sine and cosine all pass through this line. Like this x-axis here, that's the x-axis, right? That x-axis is kind of splitting the graph in half. So if I apply like a vertical shift to it, like +2, in reality what happened here is I took this axis and I just shifted it so it was up there. This is like the fake x-axis, but this is an axis that's still splitting it in half. So one thing you could do, like if I was doing the one that's up there now, I see this as 5 plus cosine 3x. So that means I've got a number here that's a positive number added to the function. So that means that since this is a separate number, it's going to be a vertical shift. So that means that I can take essentially what is my x-axis here and just say, well, since this x-axis originally starts at 0, I can move this thing up to 5 because that's how far it's moving. And I can kind of draw myself in a fake x-axis if you want. And then from there, you can kind of model what the cosine graph looks like using this new axis. When you label it, you still want to put your 4 marks down here for like the entire period, the 1/4, and so on. But when you do your points, like plotting them, you'll use the kind of fake axis, the fake x. All right? So if I go back into what we did Monday, right? My amplitude here is still 1. So my A is 1. The B is 3, which means my period should be 2 pi over 3. So this number over here is 2 pi over 3. This would be 1/4 of it, which is pi over 6. That's pi over 3 to, where am I at? Pi over 2.
How do you figure out those numbers?
This is always, that number there is always 1/4 of whatever your period is. Always.
So you just times 3 pi over 3 times 1/4?
Yes. So this is, it's 2 pi over 12, but you want to write it as the reduced thing. And then like the separation between them, like these, is always whatever this number is. So like this is technically adding another pi over 6 or pi over whatever. Or it goes like 1/4, this is 1/2 the period, and this is 3/4 of the period. Like always, that'll never change. Okay? Yeah.
So if the amplitude isn't 1, like if the amplitude is like 3, so then if you add 5, are you gonna do one like that?
You can change this to it if you want.
I mean, you don't have to do it now, but
It's easy. Look here. Oh, there's 3. All right.
okay, yeah. Can you do one like that?
Okay. Yeah. All that's going to happen is, like, if this one over here was 3, let's just pretend, for the sake of doing this, we had, let's say this was y equals 2 sine x, sine 2x. Okay. When we did this the other day, if I had a 2 right here, all that we did was we changed that to 2 and
Yeah, but then if it has a 5, if it's 5 plus that, then you're gonna go up above 57.
yeah. So like this here would be, I'm starting at 5, so if I put a 3 in front, that means I'm going 3 above and below that number. So this one would be up to 8, and this one would be at
Just
2.
subtract it and add it.
Wait,
Yes.
did you start at 3?
No. The way the way I've done this is I've taken my axis, I've shifted it. The amplitude is always, this number here is always telling you how far above and below that like principal axis is, that middle axis. So yeah, if I would have done it without doing that, I would have done like the 5 to start at 8. All right, so like if I had this amplitude here, I would put those there. And then I would go through again and just put my points like with the cosine. Like cosine, positive cosine graph starts at the highest point, goes to the middle, at the pi over 3 goes to the bottom, back to the middle, and then here. So that graph right there would be, this would be y equals 5 plus 3 cosine 3x. With this one, right down here. Okay, with this one, there's no number represented, so that means A is 1. Right here is where B would be. Okay, so that means B is 1. There's no C, so there's no vertical shift to it because there's nothing like plus at the end. And this number is being subtracted within the parentheses, so this is telling me that this right here is the phase shift, which I just had listed as D. Okay? So again, and since this is a minus, that means that the shift is to the right. Okay, so I'll start this one out like I did the other one, where I'll draw like the base graph, which would just be sine x, and then we'll shift it. Yeah.
Is D just pi over 3 or is it negative pi over 3?
Pi over 3. Yeah, this here I should. That's, okay, so since there's no vertical shift to it, I know that this A value is going to give me my highest and lowest points, right? That's going to be the amplitude. This only is going to change if you've got different amplitudes or if I've got some kind of vertical shift to it. B is 1, so that means the period is simply 2 pi because I'm not changing anything. So that means that I can come up here and do 2 pi there. That's pi over 2. Okay. Now, if you want to do this again without graphing what would be like your base graph, the y equals sine x. This number right here, okay, this number right here, the pi over 3, is telling you what to do to the values that you've already written there. So for me to actually make this like proper, I need to take all these values and add the shift to them. Okay, now this is the way to get around, oops, and there's 5 of them. This one is plus pi over 3 too. Okay, this is a way to get around not having to draw both graphs. Okay, and it also, if you do this, this will save you a lot of like messiness on the x-axis. When you're doing like the phase shifts, you'll end up with 5 values on here because the original graphs start at x equals 0, so you still have to account for that starting point. Another reason people don't like this is you start getting like a lot of fractions. You got to add fractions together, which, you know, people always hate. Okay? So what my actual graph is going to look like when it starts is going to be 1, -1 there. All right, and then I'm just going to work from left to right. Like this first point here, it starts at x equals 0. You're adding pi over 3 to it. So that means that instead of starting here, start at pi over 3. Now the rest of these, are going to be the values that I have here with pi over 3 added to them. So that means that this number here is like pi over 2 plus pi over 3. But I want it as one fraction. Don't leave it as two things added together. So what is that? It's what? Did you say 5 pi over 6? 5 over 6. So I'm going to put a 5 pi over 6 there. Okay? This one here is pi plus pi over 3. What's that?
4 pi over
4 pi over 3. Then I would move to the next one. So 3 pi over 2 plus pi over 3.
11 pi over 6.
And then finally, I would, what is 2 pi plus pi over 3?
7 pi
Okay.
over 3.
All right. Yeah.
Why is pi over 3 a ratio of 2 if you're already adding it to the other?
What do you mean?
If you have 5 increments there.
Because I have 5 increments here, but the first increment is at this point, so you can't really see it. It's the y-axis. So really what's happening is when I put this one, I'm making like a kind of a false y-axis, like if you want to imagine it that way.
Where you started from?
Yeah, so now when I draw this, if I were to do it for like one period, this would now be my starting point. So it's like this point has translated itself over to here. And since this is sine, like, so you can, if you want to pretend that's a y-axis, that's fine, just so you can visualize what it should look like. Because sine graphs, a positive sine graph is always going to have that shape. So when I draw it, it's going to go from here, then up, back down there, down and there. So the value, again, now, so like on the test, I'd be looking for those 5 points to be in the right spot. I'd be looking for these two values to be correct, and I would want to see those fractions as being correct also.
Which number, if it's negative, makes it like upside down?
Oh, in front of, like if I had a negative there. It has to be right in front of it.
And if the
Or if you had something like those, the way I had the last problems written with the vertical shifts, if it was like 3 minus cosine, then like you'd have to isolate this and realize the negative in front is in front of cosine. So now the difference between the one that was here and this one is on the function that's up there. There's kind of two things happening here. I can look at this and know that the period has to change, and I know there's a phase shift. The phase shift is usually the more obvious thing because you've got a number added or subtracted to the x. The way this actually needs to work for you to pull it straight out, this right here, this number is not the actual phase shift. Okay? This number right here is still going to represent b, but for me to get it in the proper position, to like utilize everything I had up there, I need this 2 to come outside of the parentheses. So what you actually need to write this as is I'm just distributing the 2 out from both of them. So and when I distribute this out, it's like me dividing this term by 2 and dividing that term by 2. So this one over here is actually becoming pi over 4 divided by 2. So this will become pi over 8. That would be the actual number used for the shift, just like over here we use whatever it was, pi over 3. So if you use this number, that would be the incorrect shift because you can only take this number out if the x that's with it has a like 1x there. If there's any number other than 1 with it, you have to factor it out first. Okay, so for this graph, you've got an amplitude that's 1. The period is 2 pi divided by 2, which is just pi. There's no vertical shift to it because there's no number added to the actual cosine function. So that means that this graph, if I start it, I'm going from 1 to negative 1. If I put my divisions up here, for what the simple period is, like without the shift. It would look like that. And again, I do all that just so I now know what numbers, like these are the numbers, and this one included 0. These are the 5 numbers that I need to add that shift to in order to get my new axis. So I'm gonna you have to come up there and then add all those numbers to it. Well, the same number, pi over 8 for each one of these. Pi over 8, blah, 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 blah. Okay, so when I graph it, the actual axis I'll use should be set up as, I'm starting at pi over 8, because this is the 0 plus pi over 8. Bless you. Okay, the next one is the pi over 4 plus pi over 8, which, what's pi over 4 plus pi over 8? Somebody do it for me. Pi over 4 plus pi over 8? Look at that. It should be 2, it should be 3 pi over 8. Right? 3 pi over 8. Then pi over 2 plus pi over 8 would be what, 5? So all these are going up by 2 pi over 8. So this would be 7. This would be 9. Okay? And remember, just keep it in mind, like if I do it this way, remember this first number I got here is like kind of like a fake x-axis kind of thing, or y-axis, I mean. Like this is where you're starting your 1 period graph from. So since this is cosine, cosine has that shape that's like you start up and then go down like that. So this starts up here, goes down to the middle, goes down to the lowest point, middle, and then. So there you go.